In this video I show you how to run a multi-level CFA with R and lavaan, or more precisely a two-level CFA, because currently lavaan can only deal with two levels. One assumption in the CFA is the independence of observations. You know this assumption from ordinary regression. But what can you do if this assumption is violated? For instance, if you're looking at a measurement instrument and your sample consists of students nested within classes, or time points nested within persons. In that case, the independence assumption would be violated. And if you don't deal with this violation of this assumption, you will get wrong results in your CFA. How can you deal with this? There are different options. One option would be to use cluster robust standard errors. I've made a separate video how to do that in lavaan. You'll find a link in the video description. The second option is to run a multi-level CFA. That is a confirmatory factor analysis that works on more than one level. In the case of lavaan, there are some limitations. Currently, you can only use two levels and only random intercepts, not random slopes. And it's only possible to do with continuous variables. Okay, let's start with our example. We need, of course, lavaan. And as part of lavaan, there is a demonstration data set, demo2level. We have a number of variables. I will only use the variables for one construct, y1 to y6. So 6 indicators for ideal U1 construct. And the variable cluster, which denotes which groups, that is which level 2 units, the observations belong to. So let's start with a two-level CFA. Let's say in this example we want to test whether we have a one-factor structure, whether all 6 items, y1 to y6, belong to one factor. Here's the model specification. What's new are those two keywords, level:1 and lavaan:2. Because in a two-level CFA, we have to define the model twice. Once for level 1, that is the within level, and once for level 2, that is the between level. So here is the measurement model for our factor within person, and here is the measurement model for our factor between persons. And in this first model, we assume that the measurement model is the same on both levels, which isn't necessarily true. But I think it's a good starting point. Then the estimation, model and data as normal. What's new? The parameter cluster. Here we indicate which variable in the data frame denotes the group membership. And in this example, it's also called cluster. In your example, probably it will have a different name. Let's estimate this and let's look at the output. And normally that's good. As always, we first look at the model fit before we try to interpret the results. The model test is highly significant. The CFA is extremely bad. It should be higher than 0.95. The RMSEA is bad, but the most interesting part when it comes to the model test is the SRMR, because here we get two values. One value for the within covariance matrix, that is level 1, and a second one for the between covariance matrix, that is level 2. And here we can see that on level 1 we don't have a problem. 0.029, that's a very good SRMR. So our within model seems to be good. The problem is the between model. It should be lower than 0.08, so this is clearly much too high. Here we have a problem with our level 2 model. In order to pinpoint where exactly the problem lies and what we can do about that, now we request modification indices. Here is an additional column, level. So the first 3 are modification indices on level 2, and then the next ones are on level 1. And if you look at the first 3 modification indices, it very much looks like those 3 items, y4, y5, y6, have something additional in common. So this is a typical indication that we need an additional factor. So instead of just allowing one of those error covariances, in a situation like this, allowing a new factor for these 3 variables. So that's our next model. Level 1 stays the same because that was okay. But now level 2, I split the between factor in 2 factors. One factor with the indicators y1 to y3 and a second factor for the indicators y4 to y6. The rest, the estimation and the summary function, stay the same. The chi-square test is still significant. The good news now, the fit indices are okay. 0.98 for the CFI, 0.029 for the RMSEA, and here the 2 SRMR values. So now we have a model fit that's quite acceptable and we can interpret the results. The output basically looks like a normal CFA output with lavaan, with one change. Now we get basically 2 outputs. One output for level 1 for the within effect and a second output for the level 2. Here we can see the loadings for our single factor on level 1. They are all significant, but some of the loadings are extremely low. So it wouldn't be a very good measurement instrument if it were real data and not just a simulation. Then on level 2, here we had defined 2 factors, Looking at the standardized loadings, those two factors look quite good. And here we can see that there's no significant correlation between those two factors. So we have basically on level 2, two independent factors. Another thing that's important to know, you always have to model both levels. Even if you're only interested in the level 1 CFA, you still have to define a model for level 2. But what you can do if you're not interested in level 2 is define a saturated model. And that's what I've done here. I just correlated all items with each other. So this will more or less lead to a perfect fit on level 2. And this way we can look at level 1 only later on when it comes to model fit. We don't get an SRMR of exactly 0 for the saturated level 2 model, but it's nearly 0. And now we could report our level 1 results without really bothering with the level 2 results, because those level 2 covariances were just necessary in order to calculate the model. Next to dealing with convergence issues, in our example all models converged quite well, but that's not always the case. If you have a model that does not converge, the most likely reason is that you have some kind of model misspecification. So that's the first thing you should look into. But you could also try out a different estimator, the EM algorithm. In order to estimate the CFA with the EM algorithm, you just add these two lines to the code for the CFA. This algorithm can take quite some time, therefore I would like to get continuous output to see whether the algorithm is still running or whether the computer froze up. And this is the request for using the EM algorithm. You don't have to look at this output in detail. And here we get the results, optimization method EM, and the rest of the output basically looks the same as the output we had earlier with the normal estimation method. That's it for this introduction into multi-level CFA with lavaan and R. Thanks for watching and see you in the next video.